everyone, welcome to the channel. In today's video, I want to talk about spectral clustering, which is one type of graph partitioning problem. In this particular clustering, data points are treated as nodes of a graph, and these nodes are mapped into a low dimensional space from which clusters can be formed. So I want to show this example using irisdataset, which is available in sklearn. So let's get started. So we need the required libraries. Okay, so these are our required libraries. Now we have to load irisdataset. Load iris. Data will be iris.data. Targets. Let's check the shape for data. 150 samples and 4 features. Check the features name from this command: sepal length, sepal width, petal length, and petal width. We can also check the target names as well. So there are 3 types of flowers: setosa, versicolor, and virginica. So now create a data frame. Edit our data frame. Data. Columns will be iris.feature names. We can also add the labels. Okay, so these four are features and these are labels. Now so there are each class are present 50 times in this dataset. Okay, now we can separate the features from the data frame. So df dialog, all rows and all the columns except the last one. So now I have dropped the labels. Now perform preprocessing. So scalar, scaled, fit transform, features. Okay, shape will be same as this one. So there will be 4 in this one. Okay, now scaled data frame. This number 6. Features dot columns df scale dot head. So we have scaled these features. Now they look like this. Shape is same with this one. Now this is 7. Perform spectral clustering with 3 clusters. So n clusters will be 3. Assign labels. Discretize. So I think there are few options for assign labels. Let's see. So by default it is k-means. Let's go to the description. So we can see in this description there are 3 options: k-means, discretize, cluster QR. By default k-means. K-means is a popular choice, but it can be sensitive to initialization. Discretization is another approach which is less sensitive to random initialization. So I'm using discretize here. Let's see what it does. Affinity, by default this is RBF. Let's select a random state. Okay, now spec dot fit df scaled, and then we get the breadths. Okay, now add 2 new columns. Data frame. So So previously we had 4 columns, now we added 2 levels. So now the shape will be 156 instead of 154. Okay. Let's check the unique values of these 2 columns. Sorry, ground truth. Sorry, this will be capital. So we can see 3 different levels in each column. Now clustering comparison between ground truths and predictions. This is not really mandatory for unsupervised learning tasks, but since in this dataset we have ground truths available, I am doing this. Matrix, confusion matrix, targets and threads. Okay, now let's visualize. My label will be ground truth. Font size 25. This will be prediction. X level. X ticks and Y ticks. Okay. I think the size has become a little bigger. Let's change it. Now it's more easy to see. Okay. So again, let's copy this line. Sorry. So now, okay. So 50 flowers in each class. So class 0 is Cetosa, and all of the samples in this class have been correctly predicted by this spectral clustering. In class 1 is I think particular, maybe, yes, particular. So among 50 particulars, 38 have been predicted correctly and 12 has been predicted as Pargenica. And among 50 Pargenicas, 39 has been correctly predicted and 11 has been wrongly predicted as particular. So this is how we can interpret this convolution matrix. And finally, since we have ground truths available, let's calculate a few external validation matrix. Okay. Another one, let's say mutual information. MI. So 0.672, 0.739. Not bad. Higher values are expected for these two metrics. The higher it is, the better. So this is how we can perform spectral clustering. I will give links for theoretical description. You can check those out. And that's the end of this video. Thanks for watching.